Okay, guys and girls, we're back. I'm going to run you through some of the things that we did. Looking right here in the old engine bay or whatever the area here, we moved the water temp sensor from way down here, about 3 feet from where the water comes out of the engine to about a foot. And actually, we should have that sucker right up here, just to be sure we're getting correct, exact, real-time, right now readings. And I'll tell you why that seems to be a big deal. Is when we went to the bigger pump, first we went to the test in May, Mother's Day. We're on the bigger radiator, right? Same pump that we were on before, but radiator down flat, air coming directly in instead of being scooped up and through like it was before with the old radiator. Didn't really notice much difference at all. With the old radiator, putting the old radiator down flat last October, we ran 3 or 4 or 5 laps, I think, and because it was leaking, spraying water right on us, we were done for the day. But we did notice in that cool weather, it ran a lot cooler, just changing the air box. So we were optimistic that if we put a bigger radiator that carries literally 1/3 more water, that these should be things that are going to help us cool the system down. So we put the bigger radiator in. We went and ran it. We ran about 6, 7, 8 laps of shakedown. Make sure, come in, check all the fittings, make sure everything wasn't leaking. We weren't losing any water. Then we gassed it up and we went out and ran 30 straight laps. Like I said, the water got up into the 170-ish range, 174, something like that. Looking at the video, being able to look at coming onto the front straightaway, what the temperature is. 6th gear, we see our lap time. We changed the mode from lap time to real time so we can see what the water temp and the exhaust temp's doing. And we watch the water temp come up. You know, every now and again you pause and you get an idea of what the temperatures are doing. You can also tell by the warning lights when the exhaust temperature light comes on that we're in the 1100 degree range, which isn't dangerous. It just lets us know where we're at. And then the far right warning light is the water temp light, and it's set at 170. So you can see it took 6, 8, 10 laps on the old pump, slower pump, which was 3 gallons per minute, to get up to into the 170 range. You can also see when we get off the gas at the end of the straightaway in 6th gear, as soon as we get off the gas, the exhaust temp warning light goes off, and the water temp light goes off. Sometimes it would bounce on and off down the straightaway in 6th gear. As soon as we get off the gas, it would drop below 170. Between turn 1 and turn 2, the water light would come back on and go off. Turn 2, turn 3, maybe around the back side of the track, not so much, maybe flickering on and off here and there. So that was with the temp block down there, where we're picking up the water temperature from. When I moved it up here is when we put on the bigger pump, the 10 gallon per minute pump, to take and run in July at Grattan. Much higher ambient temperature, and we also ran the same water temperature. Didn't run any hotter than it did in May, but the ignition problem came back. That dreaded rev limit issue. Now, what I did notice in the video with the bigger pump is it took 6, 8, 10 laps to get up to that 170-ish range where the warning light would come on. It was probably more than that. Oh, probably to about the 22 minute mark or so before it finally started having an issue with the ignition and the rev limit came into effect. So we were into the 170s for a while before the ignition problem reared its ugly head. But what I did notice is down the straightaway in 6th gear with this higher pump, that 170 light would go on and off, and as soon as I let off the gas, I'd pause the video and look at the numbers, and the water temperature would instantly drop as soon as I let off the gas. It was no longer making heat through the exhaust, right? It would drop 10 or 15 degrees. Bam, just like that. just like that. Turn 1 to turn 2. Temperatures would come back up. Stop the video as soon as you get off the gas. You could see the turn 3 as soon as you get off the gas. So the engineer was correct in the aspect that a higher output water pump, a pump that flowed more gallons per minute, will cool your engine better than a slower, less water volume per minute pump. He also told me that higher volume pump that'll cool your engine quicker, which we know as soon as we let off the gas and we weren't making temp, boom, that thing would cool it right down. The old pump didn't do that. It also does not cool the water in your radiator as quickly as a slow pump does. So I think that's where Brian Wilhelm and his using of a aluminum heater core compared to a real radiator is probably working for him, because the heater core is very restricted. The tubes are much smaller, they carry less water, and the fins per inch, which is another aspect of cooling, or in the case of a heater core, heat exchanging, plays a role. I mean, you can see light right through my radiator. You can barely see any light through that heater core that Brian's using, I guarantee you, because the fins per inch are probably a 3-to-1 ratio. He's probably got 3 times the amount of fins in an inch than I have in my radiator than he has on his heater core. But let's get down to the meat and potatoes. A radiator is designed to cool the water that's in it. A heater core is not designed to cool water inside of it. It is designed to hold heat while air blows across it and heats your car, that warm air. If the heat exchanger was to cool off the water inside, dang it, I meant the word, Robert. Spit the word out. The heater core. If it was actually cooling the water off, it would blow warm air eventually. If you were continue to run your heater, the heat would come out hot at first, and then the longer it ran, it'd be not as hot. Would it get cool? I don't know, but probably not. But it would be not as intensely hot. So I don't know. I mean, maybe that. Look at that. Look at what I just said. Maybe that's the whole ticket to this whole thing. Doesn't make any sense. I've used all different types of heater cores in all my days of running these enduro shifter carts, and we've done it the same way. The very first cart we built, we put the radiator right here, right in front of the engine, and we built a scoop. It scooped the air into a box. It was connected to the radiator right here in front of the motor. It was a dirt bike engine, so the pipe went up and over. It was building heat here anyway, so it didn't really much matter. But I don't know. I find it extremely hard to believe that a $50 heater core, heat exchanger, not designed to cool off water, is going to solve this problem. But what we're going to do before we do anything like that, Rick Gunther, buddy, hey Rick, what's up? He's going to come to MIS, and he's bringing us a radiator that they ran, and that's another thing that really got me thinking. Talking to Rick on the phone, he was coming up to Flint to do some shooting outdoors. He's a gun advocate like I am, and he sent me some pictures of this cart. They built this cart. Him and Mark Vina built this cart. Rick had this chassis built by Ted Swantek, and when it came to me, it still had the original nose on it. Rick sent me pictures of the cart here. That's the nose cone that was on it when it belonged to Rick. These are different side panels. It was black and white when Rick had it, but look at the massive hole in the front of that thing. I'm not sure if you can see that real well. I'm going to zoom you right in. The picture's kind of bunk, but if I can get a pointer going here, let me find something. This hole goes all the way up here, all the way down here. I mean, that is a big, massive hole. So that radiator, regardless of what it was actually a heater core, and a brass heater core at that, had a ton of air. Now, that thing would never fly at Daytona, man. Never. With a big old hole like that right at the leading edge of the car? No. But they didn't have any problem cooling off their RS-125. So hence we're going to open up the nose. You saw that in the other video where we're gonna open up the nose a little bit, and we're going to try to get some fresh air to the rotor stator. So if we don't solve our water temperature issue, we'll at least get some fresh air to the rotor stator. It won't be as hot in 2 weeks or a week and a half or whatever at MIS as it was in July at Grattan. So hopefully we'll at least on Sunday get a 45-minute run where the ignition doesn't become an issue. It doesn't, 170-degree water doesn't affect the running of the engine as long as the ignition stays underneath it. We've learned that much. So that's it. That's where we stand right now. We know the faster pump cooled the engine better. Those first 6, 8 laps, 10 laps, as it was building temperature, just the same way the old pump did, those numbers were all lower. So when we go out and run 5 or 6 laps with the higher output pump, like a practice session, and we come back in with water temp 135, 138, 142 degrees. With the old pump, it would be up into the upper 150s already just after 5 laps. So we know the higher output pump does what the engineer told us. In hindsight, we wish we would have got a loaner instead of spending $250 on it first. But hey, maybe somebody with a 2-cylinder 250 was looking at another pump. I think what we're going to do for MIS is we're going to open up that hole. We're going to get a little fresh air scoop to get us some fresh air blowing down to that rotor stator. And I think what we're going to do is put the old pump back on and put Dennis Bernier's inline thermostat here just the other side of our temp block. Because the engineer said something that didn't make any sense after I gave him the report about what happened in July with the higher output pump. He said he used the term, I forget what it was, but basically I'll paraphrase, is the water is constantly flowing at the same speed and that it can't recover quick enough or it can't keep up with the... So I don't know, he suggested putting this inline thermostat in. How that's going to cool anything off, it doesn't make any sense to me. I've told you before, I had this RV with a 400 small block that would cook the tennis shoe right off your foot in the summertime because, the heat down by the doghouse down there was so bloody bad. And it would overheat. It would actually run too hot. And so what I did is eventually I took the thermostat right out of the damn motor, and it helped the RV run much cooler. I actually stuck a hose out the wing window and ran fresh air down to my feet, down to my rotor stator, down to my rev limiter, right? But hey, all these things that we've dealt with in the past are coming to fruition with our go-kart here. So we've got a NACA duct. I don't know if we can put a little scoop, use this or not. There's not a lot of room here. If we put it here on the bottom side of the panel and then put a scoop on the top, we've got to leave that recessed 6-inch area here in this panel around the steering wheel. So it would have to be up in this area here, away from that 6-inch area. And then look where the outlet leaves us. How do we direct air down around the carburetor? And I don't know. Maybe we just do, if we're just doing an experiment and we're going to make new body work anyway over the winter or in the off season, maybe we'll just put a little PVC scoop here, and then run it through, put a hole in the panel, run some PVC up through it with a 45. We'll just spray paint it black and then just run the PVC right down in there. I don't know. We'll see what we got. We got a week and a half. All we need to do is blow some air down there to see if it helps it during a 45-minute run. That's all. And like I said, it probably won't help the water temperature. It shouldn't help the water temperature, but it may help the ignition from getting the knots. And that's where we're at. So to work then, right? God bless, Godspeed. Hope to see everybody up there at MIS. Looking forward to seeing Rick and the boys and the gang up there. Sounds like a good time. Sounds like a lot of fun. Don't know what we're going to do about a test in October. I guess it really depends on what happens at MIS. But, we're supposed to turn and burn a week later and go to Pocono and do a configuration surface test over there. That's looking bleak now. if I'm going to do that, I would have to skip MAS. I think it's just the financial portion of getting over to Pocono back. It's an 8-hour drive from here. Getting over there and back is going to cost dough. You know, and you can't drive there and back the same day. I wouldn't try to do that. So, going to need a hotel and all that kind of stuff. It's just, you know, 6 of one, half a dozen of another. If we get there, we do. If we don't, there's always next spring. I guess I really do want to get it in this fall, so we have an idea of what's going on and be able to maybe work something in for next summer. But that's it, folks. Me and the little Vortex, we're going to get to work. And we hope to see you all at the racetrack. All right? Take care. Rock on, folks.